A circle of radius 3 is tangent to a circle of radius 7. The sides of ABC are tangent to the circles as shown, and the sides AB and AC are congruent. What is the area of triangle ABC? So on the left I redrew the triangle, so triangle ABC with the two circles of radius 3 and radius 7 inside of them. And we're trying to find the area of the triangle. So we need to find the height and the base. So to find the height and the base, we're going to be using similar triangles. So to get the various points for the various triangles, I took the midpoints of the circles, so point J and point I, and then I took where the circles were tangent to the triangle, so points E, H, and K. So with these various points, we can start looking at the similar triangles within triangle A, B, and C. I'm going to be solving for the total height first, so I need to be solving for x because that's the space between A and the radius 3 circle. So the similar triangles I'm going to be using for this is triangles AJ and E and triangle AIH. So to solve for the height, I'm going to be using AJ over JE equal to AI over IH. Plugging in the values from the triangle, we get x plus 3 over 3 is equal to x plus 13 over 7. Multiplying that out, we get 7x plus 21 is equal to 3x plus 39. Simplifying that a bit further, we get 4x is equal to 18, and solving for x, we get x is equal to 4.5. Now that we have x, we can solve for the total height of the triangle. The total height of the triangle would just be the diameter of the two circles plus x. So that would be 6 plus 14 plus 4.5. That gives us a total height of 24.5. Now to solve for the base, I'm going to be using the similar triangles of AKC and AEJ. So it would be AK over KC is equal to AE over EJ. Now as you can see, AE is going to be a bit harder to solve for since we don't have any values associated with it, but we can use the Pythagorean theorem to find what AE is. So we take 3 squared plus AE squared is equal to 7.5 squared. 7.5 being the hypotenuse and 3 being the radius of the circles. Now, solving for AE, we get the square root of 47.25. Now, if you want to, you can simplify this down further and get 1.5 times the square root of 21. But for simplicity's sake, I'm going to be keeping it the square root of 47.25. Now, we get 24.5 over y, which is half of the base, is equal to the square root of 47.25 over 3. Multiplying that out, we get 73.5 is equal to y times the square root of 47.25. Dividing that, we get y equals 73.5 divided by the square root of 47.25. Now y, as you can see by my triangle and its labels, is already half of the base. So half of the base would be what I got for y. So now that we have the height and half of the base, we can solve for the area of the triangle, which is just 1/2 of the base times the height. So the total area would be 24.5 times 73.5 divided by the square root of 47.25. That would be the final answer.